Greetings, everyone. This is Feuerstein. I'm an architect for Oracle Corporation. I still get a chill when I get to say that since I just started 6 or 7 months ago. But I'm still doing the same old thing, which is reading, writing about, and offering my ideas on the Oracle PLSQL language. Thanks to ODTUG and OTN for co-sponsoring this series. This is the second in my performance section of my series. Last month I covered the result cache. Today we're going to talk about turbocharging SQL performance in PL SQL with bulk processing. And next month in December I'll talk about other performance tuning options that aren't as big as these two. So you've got my email address, you've got my Twitter handle, you've got my blog. Check it all out. Keep up to date on the latest in the world of PLSQL. So let's dive in. And in fact, I want to really dive in just by looking at code and asking ourselves, what's the problem with this code? So suppose I have an employees table with on average 10,000 employees per department. And I need to run some sort of adjustment to compensation. So what I like about this piece of code is that at first glance, it looks great. In fact, it highlights many of the nicest features of the PL SQL language. We've got a very readable language first and foremost. We have very tight integration with the SQL language, so I can have native SQL statements directly in my code. There's this wonderful cursor for loop construct, which allows me to avoid having to say, open the cursor, fetch, exit when not found, and close. I just tell it, hey, all the rows you are identified by this cursor, I want to do this stuff to it. And what am I going to do? I'm going to run some sort of procedure, adjust compensation, that probably adjusts the compensation value so everybody's getting this new salary. Maybe some people can't get that salary, maybe it has to be raised or lowered, some sort of complex computation. And then once that step is done, I'm going to update that person's salary. So it's a very nice, concise program that does an awful lot for us. And there's a problem with this code. And the problem with the code is not with the syntax, it's not with the way that you write this code in PL SQL or what you can do in PL SQL. The problem has to do with the fact that I'm executing a DML statement inside my loop. So for relatively small amounts of data, small numbers of rows, this is perfectly fine. And you might have code like this running in your application without any problem whatsoever. But if you're working with larger volumes of data, like 10,000 employees per department, or if your data is growing over time, then you might find that over time, this program starts causing problems. In other words, gets slower and slower and slower. So how can such a nicely constructed program that relies on some of the core values and the core strengths of the PL SQL language as regards SQL, how can that be a problem? Well, let's just take the lead from Tom Kite, who's really good at coining these phrases. What we're doing there is row-by-row processing. For each row, do this, then do this. Get the next row, do this, and do this. And as Tom puts it, row by row equals slow by slow. So we've got a scenario here where my PL SQL loop, the body of the loop, is executing the same SQL statement over and over again. The only difference being different bind variable values. And Oracle does an awful lot to optimize the performance of this kind of code, and certainly the SQL engine does a tremendous amount to optimize the execution of any individual SQL statement. But when we get to this row-by-row processing, we have an inherently slow situation. So SQL and PL SQL are supposed to be very tightly integrated, right? So let's take a look into the covers to understand why this might happen, why we can write code that looks so clean and concise and really nice, and yet could have some deep problems with it when we talk about production performance. Well, it's true that PL SQL and SQL are very tightly integrated, or the way to put it really is that PL SQL sits on top of SQL, and it offers the ability to write and execute native SQL statements. So there's a tight execution there. But under the covers when you're running this code, it's not quite as tight a connection. So there are 2 different engines. One engine for running the PL SQL code, one engine for running the SQL code. Almost every PL SQL code you write, program you write, is going to have PL SQL statements and SQL statements in it. You might have some very simple utility string parsing mechanisms and so on. That doesn't have SQL, but most production apps and most production programs are filled with SQL statements. And the way things work is that when the PL SQL engine encounters an SQL statement, It grabs all the values it needs. For example, here's a bind variable value. It grabs all those values and it passes the information to the SQL engine. And the SQL engine then executes the statement, does whatever is requested of it, and passes the information back. And this will happen for every single row identified by that cursor. Now, every time it switches from PL SQL to SQL, or conversely, from SQL to PL SQL, if I have a select statement that calls a PL SQL function inside of it, the same thing happens in which you switch between engines. And these context switches are one of the major bottlenecks or potential bottlenecks for performance in a PL SQL or Oracle-based application. With every new version of Oracle, Oracle certainly makes an effort to reduce the cost of a context switch. And the cost over 8 to 9 to 10 to 11 and 12 has gone down quite dramatically. So now it's commonplace for us to use our own PL SQL functions, our own user-defined functions, inside an SQL statement, whereas in Oracle 8 and 8i, it was something we avoided, really, because the overhead was so high. So Oracle will do what it can for us to reduce the cost of a context switch. But still, if you've got a lot of context switches, you're going to pay that penalty. So how can we get around that penalty? Well, that's what bulk processing is all about. So the goal here behind the approach of bulk processing is straightforward. Reduce the number of context switches and improve performance. Period. And to do this, Oracle essentially implements array processing for us in which we can bundle up the requests for data, or to change the data, and then pass them from the PL SQL engine to the SQL engine with a single context switch, instead of doing it for each individual row. Now, there are two parts to bulk processing in PL SQL. One is FORALL, and that's a new statement. It's really an extended DML statement that is used to speed up non-query DML. So DML means data manipulation language. We usually think of DMLs as inserts, updates, deletes, and merges, but theoretically, select statements are also DML. So the correct term is actually non-query DML there. And the basic idea with FORALL is that you put data into collections, array structures in PL SQL, and those are pushed into tables, one more tables. Bulk collect is the reverse. That's the syntax that you use to enhance or speed up your fetching of data. So that instead of fetching into or selecting into, you bulk collect into. And in that case, you can use it with all kinds of queries: implicit, explicit, static, dynamic, and you move data from tables into collections. And then you work through the contents of the collections to sort out what you got back and what you need to do. So FORALL and bulk collect. By the way, these features were introduced in Oracle 8i. They've been enhanced steadily since. So they've been around for a long time. And in a way, hopefully, I'd like to think that all of you know about these features and are using them. But in a way also, just to, sorry, I'm going to jump back. I can do this quickly. I want to go back to this problematic code. In a way, a part of you would like to hope that some of you are looking at this code and through this presentation and thinking to yourself, oh my gosh, I've got programs like this all over the place. I can think of dozens of places in which I have cursor for loops and other kind of loops with DML inside of it. If that's the case, then you're in a really great position because you will be able to improve performance dramatically. There's a significant amount of work to do in terms of code changes, but you'll be able to make significant improvements in performance. This is low-hanging fruit. And when it comes to performance improvements, sorry, just going to cruise through here, it's way better to be able to identify low-hanging fruit for improvements and apply those as opposed to slogging through thousands of lines of code trying to figure out ways to make microsecond improvements. So let's take a look. Now what I'm showing you is a different picture from the previous movie in which I had a for loop with a DML statement inside of it. Now I've got a FORALL statement, essentially a header that sits on top of my DML statement. And what I'm going to do is bind in an array. And we'll talk about the syntax in a moment. But the basic idea is that the profile of execution now changes dramatically. Now when the PL SQL engine encounters this FORALL statement, it says, oh, I know what you want. You want to execute the same statement for different values from the array. So you know what I'm going to do? I'm going to bundle those all up for you. I'm going to generate your 1,000, 10,000, 20,000 DML statements, all with their different line variables. I'm going to pass them across to the SQL engine with a single context switch. The SQL engine is going to do pretty much the same thing it did before, and then it's going to pass the results set back. So a drastic reduction in context switches. So Oracle's providing you a different kind of syntax, and while the change here looks relatively straightforward, the real-world conversion from old to new, from row by row to bulk processing can be traumatic in some cases, certainly quite complex. But the benefits of improvement are quite remarkable. So that's the basic idea. Let's talk about the impact of bulk processing in the SQL layer. So what we're talking about really here is we're changing the way that we use PL SQL to interact with the SQL layer. So we're going to change our PL SQL code to tell the PL SQL engine to communicate with the SQL engine differently. You'd like to think, therefore, that the SQL engine is not going to be changing what it does. And that is pretty much the case. There's almost no change on the SQL engine side for doing bulk processing versus row-by-row processing. You get the same transaction and rollback segment management issues and possible errors. In other words, if you got a rollback segment too small error because you were trying to update 1 million rows row by row before, you can now get that same error way faster than you did before. The same number of individual SQL statements will be executed. If I was doing 1,000 different update statements, I'll still do 1,000 update statements, but it'll happen all within the SQL engine, not bouncing back and forth. The only difference I'm aware of is that if you have a before or after statement level trigger on your table for insert, currently, without FORALL, that trigger would fire, each of the statement level triggers would fire for each individual insert statement. But they only fire once per FORALL insert. You can check out the script, statement trigger in FORALL.SQL, to demonstrate that behavior. I won't run it in the course here, we don't have enough time. And I will give you instructions on how to find that code when we're done with this presentation. But the basic idea is go to the Oracle Learning Library and search on PLSQL, and you'll find my demo zip script. But I'll come back to that in a moment. So essentially what you have is a change in the way you write your PL SQL code to interact with the SQL engine differently. But the SQL engine stays pretty much the way it was before. Okay, now we also need to discuss the impact of bulk processing on memory consumption. So to use these features, bulk processing, you will utilize collections, array structures in PL SQL. I hope that all of you are familiar with and have comfort using collections. If not, I'm not going to be able to handle that issue in this class, but in 2014 I'll run some classes specifically on the collections feature. So the array structures in PL SQL are very powerful, very important for you to utilize, especially since they are at the core of virtually any performance enhancement feature. The problem, though, is that when you utilize collections and you're not careful about how you do that, you can end up providing or having the users end up with ugly memory errors running out of memory in your session. So to understand why that can happen, and then we'll talk about how you can manage some of those memory issues, let's take a look at a very simplified map of runtime memory in the Oracle database. So every time Oracle or a DBA starts up a database instance, Oracle grabs a chunk of memory called the system global area, or shared global area. And it's essentially an enormous cache, and the idea here is that data stored inside the SGA can potentially be shared across multiple sessions connected to the Oracle database. So for example, if session 1 and session 2 both call the same calc totals program, then Oracle will make sure that the source code, the partially compiled source code for calc totals is loaded into memory, and then we execute that same body of code. If multiple programs like calc totals and showMs all execute the same SQL statement, Oracle will keep those pre-parsed cursors in the cache and will avoid reparsing. So Oracle does an awful lot to share data to avoid excessive processing that's not necessary. Great. But in addition to the SGA, for every session connected to Oracle, there is a localized PGA process global area and associated closely with that user global area. So process global area is the area that contains the memory for any of the process-specific variables. So when you declare a variable, a record, a collection, etc., in your PL SQL programs, Oracle will consume PGA memory for that session. And the memory, the PGA memory, is constrained by essentially an operating system limit as to how much memory can be allocated per process. And you can definitely hit the limit. And then the process fails, the session fails. And you really want to avoid that happening, obviously. So this comes to the fore whenever you're working with collections. It's not a specific issue for bulk processing, but you're never going to use bulk processing without collections. So you got to be aware of this. So let's see if I've covered all the details. This is probably a good example of a little bit too much information about PLSQL, but what the heck? That's what I'm for, right? So I'd already mentioned that the process global area contains session-specific data that's released when the current server call terminates. So if I'm done running my program, the local variables for that procedure are released. The memory is released. If I have package-based variables, the user global area will contain data that persists across server calls, my package level data. But it's all pretty much wrapped up into a single number process global area if you wanted to analyze those numbers, and I'll show you how to do that on the next slide. There's a slight tweak though. If you have a package that contains a static constant, and a static constant is a variable declared as a constant, whose value never changes across different sessions and different users. So if I have 1,000 different users using this package, static constant will always have a value of 42, but for all 1,000 of those sessions, non-static constant will have a different value. We're generating it dynamically when the package is initialized. The memory for this static constant is stored in the SGA, not in the PGA, because if it's the same across all sessions, it's a candidate for SGA storage. It's a very minor issue. That's not something that's probably going to change the way you write your code or memory management in your applications. But like I say, TMI for PL/SQL. It's my middle name. So process global area is the thing we need to pay attention to. We need to make sure that it's not getting too big. And the question then, of course, is, well, how do you do that? You can calculate PGA and UGA consumption by looking at a variety of $sign views, session statistics, statistics name. So Oracle keeps track of all this information as the database is running for each session. And if you have select authority on those $sign views, you can analyze your code's memory usage. So now what I've done is build with actually a friend of mine, John Bresnovich, a package called PL/SQL Memory. And this package allows you to hide all the details about these views, because you really don't want to have to remember all that stuff over and over again. And exposes a very simple API, a set of procedures and functions, so that I can say, start my analysis, run my application, show my memory usage. And that will automatically calculate and show me the PGA usage. Let's take a look. Yes, enough PowerPoint for a moment. Come back screen. Thank you very much. Oops. So the PL/SQL memory package, again, is a simple API. It provides a set of 3 procedures to do the work for me, and it hides all these details. It's a great example of the power of packages, essentially, and the benefit of building APIs. I don't want to have to remember all these details. I hide it behind a procedure, in this case, a function. I build my other code, and then I can simply use it. So let's compile this stuff. Actually, I think that I won't run it now. I'll just show you this code, and I'll show you a demonstration of how to use it so we can stay focused on getting through my content, which I usually run out of time for. So here's an example of putting it to use. I've got a global variable at the package level. I've got a local variable at the package level, at the block level. And then I have my pseudo application, which populates each of the arrays with 100,000 rows of information. I start my analysis, run my application, and show the results, which calls the show memory usage procedure. So feel free to download this code, install it, try it out yourself. You can either do this, or you can say, well, I'm not going to worry about memory consumption. I'll let the DBA know, or I'll let the DBA let me know when there's a problem. And you may have to do that if the DBA is not willing to give you your $sign access. But in general, I think if you can get the DBA to grant select on these views, you're much better off proactively analyzing the kind of PGA consumption you might be experiencing. All right. Let's get to it. Bulk collect. So we want to do multi-row querying. We're not fetching 1 row or 2 rows or 3 rows. We're fetching thousands, tens of thousands of rows. And in this case, bulk collect can help us an awful lot. And basically the way it works is that anywhere you've got a select into or a fetch into, essentially an into, you can put bulk collect in front of it. So for static implicit queries, for an explicit static query, or even against a cursor variable, and dynamic SQL. Just put bulk collect in front of it, and then you can populate 1 or more collections directly from all the rows identified by that result set. And of course, it's not just a table, It could be a view, a join, whatever. Note that no data found is not raised when no rows are fetched. It's kind of like doing a group function. It'll simply leave the collection empty. In fact, the collection is empty for each different fetch, and then it's simply not populated anew if no rows are found. The collection that is populated is always filled sequentially from index value 1. So there are no gaps, there's no sparseness. You can't say I want to start at row 100 and go to 175. That's the way it works, from 1 to the index value returned by the count method. You can only use integer index collections and no string index collections. And if you're using nested tables and V-arrays, there is no need to initialize or extend. Oracle will do that for you automatically. Now again, if you're new to collections, you may not know what I mean by a nested table and a V-array versus an associative array. Don't worry about that too much for this presentation, but you definitely want to fill out your knowledge about collections. So here's a very simple piece of code that demonstrates the power of this feature. So I declare a nested table. It's a table of employee records. I'm emulating my employee table very easily. I declare my local variable. My select statement simply adds the word bulk collect in front of into. And then I provide the collection, and that gets me all the contents of the employees table, and drops it into my array. And then I can iterate through my array, and I can go from 1 to the count, because I know that it's either empty, in which case count is 0, or I know that it's sequentially filled. So a for loop will not lead to any sort of no data found exception. And then I can work with my individual records. And this is an individual record from the employees table, each individual element in my collection. Well, that's very nice, concise code, and it expresses the power of bulk collect so nicely. So, what's wrong with this code? Here's the same code that I just showed you before, and I thought, oh, I was telling you, this is very concise, powerful, and wonderful. What's wrong with this code? This code has a big problem. And the way to think about chunks of code like this, when you ask yourself what's wrong with the code or what could be wrong with the code, has to do with making assumptions. Almost every time we write a program, we make an assumption. And if we don't make the assumptions explicit and validate those assumptions, they can lead to some pretty tricky and hard to track down bugs in the future. The problem with this code is that as the data volume grows in my employees table, this program will consume more and more PGA memory. And eventually, it might cause a crash. And this is a classic scenario, but sort of a nightmare scenario for developers. I write this program in 2010, and I move on to my next company, my next project, and it stays inside the company. And the employees table grows and grows and grows, and 5 years after I leave, 10 years after I leave, nobody's touched that program. Everybody's been really impressed that it keeps working, and we don't have to worry about it. And then in 2015, it explodes. And suddenly, you're faced with having to go into somebody else's program that's not been changed, and yet is now causing a problem to figure out what went wrong and how to fix it. So what you want to do instead when you write code like this is either explicitly list the assumption in the comments so it's easier to track down and understand. More importantly, though, or better, is to anticipate the problem and avoid it. So the bottom line is that when you're writing production code and you want to speed up your fetching of multiple rows, do not use an unlimited bulk collect. This leaves you vulnerable to PGA memory errors. Instead, use the limit clause. Limit retrieval, still use bulk collect, but constrain the number of rows you're going to get back at a time. Now, there are roughly 2 ways to do this. One is that you can use the V-array, which is a special kind of array that forces an upper limit on the number of rows that can be held in it. So you can essentially say that this program is fun, but if it ever gets to have more than 1,000 rows in the employees table, I want it to just break. I want it to break. I want it to stop, raise an error so that we can go in and figure out what's going wrong because the table shouldn't get that big. So that would be the idea behind using V-array. If there's that much data in the table, something's wrong with the table. But that's usually not the case. Usually the case is that your tables are grown, and the problem is your code. So in that case, when you don't know an upper limit for your table contents, you want to instead switch from an implicit query to an explicit cursor, and then fetch bulk collect with the limit clause. So this is the kind of code that you should be thinking about writing in production, or at least it's closer to it, in which I've moved my select statement up to the declaration section. I declare a collection based on that cursor percent row type to keep them tightly in sync. I open my cursor, and then inside my loop, I fetch bulk collect into, and I say, I only want to get up to 1,000 at a time. So let's say I've got 100,000 rows. I would do 100,000 fetches, 1,000 each time. When my collection is empty, I will stop. And then I'll process all those employees. So this way, you can essentially look at the size of the record that's being retrieved. You can multiply the number of rows. You can actually run this test in dev or test and use the PL/SQL memory package to see exactly how much memory is being utilized. Then you have to multiply that by the number of concurrent sessions doing the same thing, because PGA is going to be copied for each one. And then you've got a total amount of PGA, and then you go to your DBA and you ask, is this going to work, or is this going to be a problem? If it's a problem, lower the number, adjust that number, and that controls the PGA consumption. So a few more details on the limit clause. It can be a literal, like I just showed you. It can be a variable. I suggest strongly that you do not hard code your limit value. Instead, pass it as a parameter. That gives you maximum flexibility. Or maybe have a package level constant whose value is changed, though that's a little bit too global probably for this situation. But do not hard code the value. A limit of 100 seems like a good default value. You can set it higher, 500, 1,000, and it doesn't seem to make that much of a difference. But certainly we've seen more extreme situations where you're dealing with massive amounts of data, and the larger limit was helpful to developers. So for most scenarios, starting with a limit of 100 is probably good enough. But do be ready to experiment with different sizes of limits. You have to make sure you've got enough PGA memory, and then you can examine if it does make a difference in performance. Another thing to think about when you're working with bulk collect and limit is how to terminate the loop. So a classic problem we have as developers is that we fall into ruts. We develop habits on how to write code, basically patterns of how we write code. And we just do that without even thinking about it. So for example, with single row fetching, I would fetch a row and then immediately exit when percent not found, cursor percent not found, because I didn't find a row. If you take the same approach with bulk collect into, you could lose processing of some of your data, because I might have fetched the last 3 rows with a limit of 100. It's certainly under that limit, so I fetched the last 3, the last hangover set of 3. And that means that my cursor is now exhausted, but my collection has some work to do. Let's take a look at the script. So this script, bulk limit stop, contains a number of different approaches, compares a number of different approaches to terminating. So I fetch bulk collect, and I immediately exit. So this is the pattern that we're used to, and it's the wrong pattern for this code. I could fetch bulk collect and then exit when the collection is 0, because that's what the collection means. When it's 0, it's empty, nothing's been fetched. I could fetch bulk collect, do my work with the collection, and then exit when not found. That'll work out okay. And I can also say fetch bulk collect with my limit, exit at the bottom of my loop when the count is less than the limit, because obviously I didn't hit the limit, which means I've exhausted my processing. Let's run the script and take a look at what happens. So what you can see, I've got a limit of 3, and I've got 4 rows. So let's go to the second one, which is working correctly. I fetch 3 rows, I process 3 rows, I fetch 1 more row, I process the row, I fetch 0 rows, I stop. Let's look at the first one, which is exit when percent not found right after fetch. I fetch 3 rows, I process those rows. I fetch 1 more row, and wait a minute, I don't do anything with it. And that's because percent not found is true. The curse is exhausted, the collection is not, so you've got to remember to keep them separate. And if I do my count equals 0 to terminate, or I move percent not found to the end of the loop, or count less than limit at the end of the loop, then I will process everything. It doesn't really matter which of these approaches you take. Some people feel very strongly that you should not use the percent count, sorry, the count equals 0 right here, because that means that you do a last fetch. You do an extra fetch of fetching 0 rows. But I think the cost of doing that fetch is really quite minimal. And the main thing is to have maximum readability in your code. But the most important thing of all is do not do the old way of doing things, following that pattern through. So once you convert to bulk collect, prior to 10G, if you ever see a loop that contains DML, you should convert to bulk collect. I'm sorry, if you ever see a multiple row fetching, and certainly including cursor flow loops, convert to bulk collect. but I'm assuming that you're all past 10G at this point. On 10.1 and higher, the optimizer, the PL SQL optimizer, will automatically optimize cursor for loops to run at performance levels similar to bulk and FORALL. So it'll automatically optimize cursor for loops. Let's just pull up that piece of code. I'm not sure why the switching is so slow here, but it is. So here's a cursor for loop. Doesn't do anything, but it's looking through 100,000 rows of data, whatever. So this is a high-level declarative statement that tells Oracle, hey, I want to go through each row in my cursor and do X. I don't really care how you get the job done for me, just do it. And because I've stepped back and declaratively defined what I want Oracle to do for me, the optimizer can step in and say, I'm going to convert this row-by-row processing to fetch 100 rows at a time. So it effectively acts like a bulk collector. Really nice. If I write the code myself, here's an explicit program to iterate through my cursor. Oracle cannot optimize this code to use bulk processing because there could be potential side effects. Bottom line, the bottom line is that if you have a cursor for loop and it does not contain any DML operations, in other words, it's a read-only for loop, it's not doing any inserts, updates, or delete, you can probably leave your cursor for loop in place and not explicitly convert to bulk collect. Possibly if you do make an explicit conversion, it will run a little bit faster than cursor for loops, but probably not at the level of performance that you would ever notice. So read-only cursor for loops, leave them as they are, and you should be fine. But if you have a cursor for loop or any kind of loop with DML inside of it, then it's a different story. So concluding on bulk collect, and we'll move on to FORALL. Bulk collect will improve the performance of queries that retrieve more than one row. And in fact, in the Oracle doc set, they say that if you are fetching 4 or more rows, you will see a benefit of performance improvement, which is pretty amazing. But it's not likely to matter until you're working with hundreds or thousands, certainly thousands and higher rows. Use that limit clause in production code to avoid excessive PGA memory consumption. And whenever possible, leave the optimizer to do its job and speed up those read-only cursor for loops. Do not explicitly convert them. Okay, I've got 25 minutes left, and I want to cover the most important topic for bulk processing, which is FORALL. Bulk collect's great, and it certainly improves performance of queries, but it's a relatively simple construct because you're doing queries. And queries don't have as much complexity, they don't have as much performance impact as the non-query DMLs. So FORALL is the more important of the two. I'll do an introduction. We'll talk about figuring out how many rows have been modified by each of your statements. And then we'll essentially go through all the details. So, FORALL. So the idea behind FORALL is you essentially replace the for loop with a FORALL statement. So it's an extended DML statement. It sits on top of a single DML statement. And the header for that FORALL statement usually, but not always, will look like a numeric for loop, in which I have an implicitly declared iterator. I have a range of values, and then I have my DML statement. And at least in one place in that DML statement, I have to reference a bind array and that iterator as its index value. So that's the pattern that the PL SQL engine will look for to say, aha, I know what you mean. You want me to generate all those statements, pass them over to the SQL engine, all that kind of stuff. This is what does it for you. All you've got to do is have the reference to one or more bind variables, and then using the iterator as the index value. Now, in terms of the performance impact of this, what you can generally expect to see in my experience is an order of magnitude improvement. So if you have a set of inserts or updates that are taking 5 minutes, let's see, 5 by 60, 300 seconds, then you should be able to bring that certainly down under a minute and maybe more like half a minute, a very significant improvement in performance, and sometimes even better than that. I offer a lot of scripts with variations on syntax, and you can run your own script for timing. I'll leave that to you because I want to make sure I get through all the features of the FORALL statement, but I do encourage you to run these scripts, try them out for yourselves, and prove to yourself that you will see benefits in performance improvement as I mentioned. So that's the basic FORALL statement. How do we get around? How do we get to using it? You can use it with any type of collection, nested table, V-array, associative array. The biggest constraint for the FORALL statement is you can have only one DML statement per FORALL. Now, it's very understandable as to why you would have those restrictions. The problem is that in any real-world program, you don't have single DML operations. Usually you have a transaction of multiple related DML statements. And then it can get very tricky to convert to bulk processing. Your collections have to be indexed by integer. The bind array must be sequentially filled unless you take advantage of some new syntax in 10G2 for indexes of and values of, which I'll come back to. And you basically have to keep things simple in your FORALL statement. You can't have indexes that are expressions. They just have to be the iterator in the FORALL statement. Okay, well, let's see. Let's just look at a couple of examples before I dive into how you can use various elements of FORALL. So we'll open the FORALL examples file. So here's an example of FORALL with delete. I declare my associative array. I set up two values in it. And what this will basically do, and here's my iterator, here's my collection, and there's the iterator as the index value. It will basically execute a delete statement for row for ID 138 and 147. Here's an example of FORALL with multiple arrays. So I can have as many arrays as I want in the set statement, in the where clause, etc. I just need to make sure that the index values across those different arrays correlate properly, because that's what will happen. Oracle will take this iterator and will apply to all the different collections. So if your data is out of sync, you're going to end up with some really messed up data. But it's certainly possible to do that. So there are a lot of things we need to know when we're executing a DML statement. For example, how many rows were modified. Now, the SQL% row count implicit cursor will give us information about the number of rows modified by the entire DML statement, and what that means in this case is the entire FORALL statement. But you can also use SQL% bulk row count, a pseudo collection that is generated by Oracle that will tell us how many rows were modified by each individual statement. Let's take a look. So without going through all the details, here's a much more complex FORALL statement, so let's take a look at that. For all the indexes in 1 to the e-named filter, I'm basically setting up a filter saying do updates for everybody whose name starts with an S, starts with an E, or contains an A, because they're the ones who deserve a raise. Sure, why not? And then what I've done to make this really interesting is I've added a return clause. So returning has nothing to do with bulk. It was added in Oracle 8, and it allows you to get information back from any DML statement, avoiding a second select and reducing context switching. So I'm getting back my employee IDs, and because I might be updating more than one row, I need to say returning bulk collect into. So right inside my FORALL statement, I can have a bulk collect. And I'm going to populate my array of numbers with all the employee IDs that were modified. Now, after my FORALL statement runs, I can see how many rows were modified by that statement. And this will give me the total number of rows across all the updates executed. If I want to understand how many rows were modified by each individual statement, I would go through a for loop against the filter, the bind array, because those are the number of statements that were executed. And for each one of those statements, I can take a look at SQL% bulk row count at that position. And that will give me the number of rows modified by each individual statement. So for example, you might have a rule that in the program you're running, every single DML statement has to update at least one row. If any of them update 0, something's wrong. So you can iterate through this list of filters, your bind array, after your DML statement. And if this value is 0, then raise program error, or whatever you would do. Log the error. Something went wrong. So that's how you might want to use this pseudo collection. If you're not yet on 11.2, then one of the restrictions you can run into with PL/SQL, with the FORALL process, is that if you have a collection of records, you might have to break it up into individual collections. So let's just really quickly look at this. Come back. Well, that's interesting. Try it again. Much better. Oops. I forgot the name. Field of records. Oh, I've lost my, no? What's going on? So here's a collection of records defined on 2 columns. And if I'm not in 11G, I cannot use the syntax collection index value dot field. That will not be supported. What you can do is do record level updates and inserts. So in case you didn't know this, you can say update a table, set row equal to a record, and it will update the entire record, the entire row with that record. I can even say insert into a table values and provide a record, not inside parentheses, and it will insert that entire record. So if you're not yet on 11G, there are ways around this problem, but essentially from 11G onwards, you can reference fields of collections of records. I should probably just drop that slide since it's getting kind of old. Using FORALL with sparse collections. So for those of you who have worked with collections for a long time, you'll know that sometimes your collections are not filled from 1 to n with every value in between filled. There might be gaps. You might not start on 1. You might start on 25 and then have gaps. And in those cases, you can't use the traditional in low to high syntax of the FORALL statement. You'll get an error. What you can do instead is use indices of or values of. It's a really nice nuance to the syntax. Let's take a quick look. So here I've got a collection of employee IDs. And notice they're not densely filled. I've got index value 1, 100, 500 defined. And if I say go from first to last, so 1 dot dot count, and I run this piece of code, it gives me an error and it says element at index 2 does not exist. Because this works just like a for loop. It says I'm going to start from 1, I'm going to go to 3, 1, 2, 3. And when it hits number 2, there's nothing there for number 2, and it blows up. So in those kinds of situations, what you want to do is switch to indices of. This says, for all the indices of this collection, 1, 100, 500, do the updates. Now when I run this code, anonymous block completed, no error. So when you've got a sparse collection, switch to indices of. There is a lot more you can do with indices of and values of as well. There are a number of interesting nuances to it. I'll leave that for you to explore on your own time if you run into this scenario. But certainly, you can always switch from the low to high approach to indices of and avoid having to manipulate your collection to get rid of those gaps. Okay. Now, of course, one of the biggest issues you have to confront when you're executing DML statements, inserts, updates, deletes, are errors. All sorts of errors can occur when you execute DML compared to, for example, a query. On top of that, FORALL statements are typically used to execute a large number of DML statements, not 1 or 2. And that immediately raises the question, what should happen when one of those statements fails? Because by default, it's pretty clear. If I've executed a DML, if I execute, let's say, 1,000 DML statements in my FORALL statement, or I want to execute 1,000, and let's say I get through 500 and they completed successfully, and the 501st update statement, which was going to update 35 different rows, failed. One of the rows it was trying to update had a value that was too large for the column. What happens? Well, first of all, that statement is rolled back entirely. So if that statement was going to update 35 rows and it updated 34, and on the 35th got an error, all 35 rows are rolled back. But the previous 500 statements that completed successfully are not rolled back. You have to decide what to do about those. And this is true generally of PL/SQL processing. If you've previously completed an SQL statement successfully in your session, a failure in a subsequent SQL statement will not force a rollback. On top of that, we have to ask ourselves, do we want the FORALL processing to continue? So if I hit that error, if I hit that statement, do I want to keep going or do I want to stop? Often with a bulk process in which I have tens of thousands of statements that I'm going to execute, I'd want it to keep going. Keep track of the statements, the errors that you found, and let me know about it when you're done. And we can do that with the save exceptions clause. Very nicely named. So the idea behind save exceptions, we simply add that clause into the list, into the FORALL header, sorry. And it says, if you get an exception, save it, save the information. And then, when all the statements have been executed, if at least one exception did occur, then raise OR 24381. Unfortunately, Oracle has not given a name to this error. It should. We should. Not going to know with Oracle. But that's okay. We can give it ourselves a name if we have to, if we want to. So let's take a look. That's some code. So what I've done here is create an array with 5, 6 different names that are potential first names. So I'm going to run a really dumb piece of code in which I update the first name with that modified name for everybody in my table over and over again. Wow. Now, 4 of those names are okay first names, first, second, fourth, and sixth. The third and the fifth are way too big. Now, if I take out save exceptions and run the script, here's what I see. I updated 214 rows, and then it stopped because the value was too large for the column, first name. It had a size of 1,000, and the maximum was 20. Now, the reason it says updated 214 rows is that in my exception section, I trapped others, and I got the SQL row count. My employees table has 107 rows in it. It did the first 2 successfully, so it updated 214 rows, then it failed, and then it didn't do the rest of these. And if that's what you need, that's the behavior you need, we're done. But again, in many cases when we're doing bulk processing, we want to keep on going. So I'll add the save exceptions clause. I'll run my script again. And now my output's a bit different. Now it says, updated 428 rows. Well, first of all, it says your error was 24381. And then it says, I updated 428 rows, and the first error occurred on index 3. Try and update the name to this really big string. And the second error occurred on index position 5. Try and update the name to an even bigger string. And then it showed me the error message. So this is really nice granular error tracking. And the way that works is that in my exception handler, I can track for 24381. Now what I could do is write it like this. When others, if SQL code equals negative 24381 then, I strongly encourage you to never write code that looks like this. People don't like to read things like if SQL code equals negative 24381. It makes them feel dumb. There are probably a half dozen people in the world who, when confronted with that number, would know what it means. There's Brindlewell, the product manager. There's me, maybe 1 or 2 people on the PL SQL development team, and then who knows who else. So when you write code like this, what you're basically saying to people, even though you might not have meant it, is, haha, I'm smarter than you are, and you should be intimidated by my code. Well, you don't want to intimidate people with your code. You want them to feel welcome and comfortable, not having a nervous breakdown when they need to change it. So what I'm doing here is declaring an exception, using the pragma exception init to associate that exception with that number, which is what Oracle could do, and we should do in the standard package at some point. And then I can trap it by name. So when there was a failure in the FORALL, well, I can get my total number, 428, which is 107 times 1, 2, 3, 4, 428. And then I can iterate through the SQL% bulk exceptions pseudo collection. It's a pseudo collection of records that Oracle generates for us and populates. It has 2 fields. The index into the binding array in which the error occurred, the first and the third in this case. I'm sorry, the third and the fifth. And it has the error code, the error number that was raised at that point. And as you can see in my output, I was able to show you the error message. And that's because I took the error code and passed it to the SQL error message function. And unfortunately, I had to multiply it by -1 because sometimes we think error codes are positive and sometimes negative. The SQL error message thinks they're negative. SQL bulk exceptions thinks they're positive. So we have to do that little conversion. And then we can see the error message. I mean, more likely what you're going to do is iterate through your bulk exceptions and simply call your logging package, error logger, log error, and pass it the information. You might even say things like if the error code is equal to negative or positive 2045 or whatever it might be, then do some sort of recovery. So you could do granular statement by statement recovery or simply log the information out. But at least you're able to grab all the information, you were able to complete all the DML statements that you could. That to save exceptions, a very powerful feature. And the one thing I really love that we can add, and who knows, it might happen in the future, it's not available now, is to not only grab the error code, but the error message, so we have the full error message information, which we currently don't get in some cases with the SQL % bulk exceptions now. I think I've pretty well covered all that. Let's finish up. So I've got a couple of slides here about how to convert to bulk processing from the old approach. I'm going to cover this at a high level. I'll show you some scripts that you can look at and really explore it in more detail because we'll run out of time before I can do it entirely justice. But this is one of those features that are pretty tricky to implement. For those of you who attended or viewed my last month's webcast on the function result hash, that was an example of a feature that required very small change to your code, simply adding one clause to your function header. Now, it didn't mean that you shouldn't very carefully decide when and how to do that, but you weren't looking at major changes to your code base. With bulk processing, that's not the case. Moving from old-fashioned row-by-row processing to modernized or high-volume bulk processing involves a very fundamental change from integrated row-by-row to phased processing. Challenges include when I have multiple DML statements in the loop. Now, in an integrated approach, they were all part of one block, one transaction. Now they're going to be phased, all the inserts, then all the updates, then all the second updates. We have to figure out how to communicate from one DML statement to another. And always, always, we have to remember to watch out for excessive PGA consumption. So here's an example of code that's probably a little bit more real world than what I showed you to start off this session. I've got a cursor flow loop with DML inside of it, so this is a candidate for conversion to bulk processing. But I have an insert, then I have an adjustment for compensation, then I have an update. So multiple DML statements with a lot of entanglements. For example, and if anything goes wrong, log the error and keep on going. And notice that if my insert fails, my update statement should not execute. So there's a relationship between my DML statements. And when I convert to bulk processing, I have to make sure that I cover all of these things. And in fact, in general, putting aside the issues of the specific code changes, which I'm about to show you, the most important thing for you to do when you're faced with looking at a beautiful piece of low-hanging fruit like this is a prime optimization candidate. The first thing you need to do is document really clearly its current behavior so that you can make sure that you mimic it closely when you move to bulk processing, because we're talking about DML operations. This is going to be critical transactional stuff. You've got to get it right. And the only way to get it right is to document how it works, number one, and number two, ideally, build an automated regression test to verify it. Now, you're probably not going to do that, but at least you can write a list saying, okay, if my insert fails, my update shouldn't execute. If any of them fail, I want to log the errors and then keep going, which means, of course, to save exceptions. How do I do that? Okay, how do you do that? Well, as I mentioned, you're going to be moving to a phased approach. And I see things as being essentially in three phases, though you don't always go 1, 2, 3, as you're about to see. But the basic idea is that you're starting with data in your relational table or tables. You're going to use bulk collect to get the data out of tables and populate collections. In some cases, you might not even have phase 1. You might already have data in collections from some other scenario, and you're simply using those to drive the DML. But often, we bulk collect out to modify and push back in. Phase 2, modify the contents of your collection essentially to get them ready for the pushback. The FORALL statement should be nothing more than a quick, fast, clean push to the database. So you might want to go through those various collections you've populated and identify, I want to do that one, I want to do that one, I want to do that one, I don't want to do these. So essentially pre-manipulate your collection. And then phase 3, push it back to the table or tables. Hopefully those three phases make sense. Let's take a look at translating those into code. And then I'll finish up. Now in the demo zip script that you can download, and I'll give you the directions for that in just a second, you're going to find a lot of scripts that are called CFL to bulk. 0, 1, 2, 3, 4, 5, et cetera, et cetera. And these all come from a class I put together on refactoring years ago in which I show step by step the changes that you should make. Now I'm not going to do that today. I'm going to start with my starting point, and I'm going to also go to my endpoint, and we'll just compare them. And then I need to get rid of some of this code. too many scripts. Okay. So here's my original code. It consists of a relatively small and easy to read and understand program, 30 lines long. I do my insert, I adjust my compensation, some sort of complicated formula, and then I do my update. I log the errors if anything goes wrong, and keep on going. So it really works well, but the volumes are increasing, the performance is going down. So here's what it would look like, roughly speaking, when I move to bulk processing. First of all, it's now 60 lines long. It's twice as long as it was before. And somehow this doesn't look right. This is not what I want to do. I think I wrote over it with something else. Let's see. Okay. This is more like it. Whoops. It's 138 lines long. It's 4 times longer than it was before. And it's much, much more complex. So that's the price you're going to pay, increased complexity. Inside my loop, I've got a cursor to get all my employees. Inside my loop, I fetch the next set of rows, the next 100 or 1,000 rows. And that is determined by my parameter, which has a default of 100. And I also declare my exception. Okay, going back down to the bottom. So I fetch a number of rows, exit when there's nothing left. Then I'm going to do, that's my phase 1. Then I'm going to do insert history. That's phase 3. Push it back to the database for my audit rows. Then I'm going to modify the contents of my arrays. That's my phase 2. And then I'm going to do my phase 3 of updating employees. Now here's my insert history. That's my first FORALL operation. So I can simply say go from 1 to the count of my sequentially filled collections, do my inserts, save exceptions if anything goes wrong. So if something goes wrong, as in the original, I want to log the error and then keep going, but also remember, I skipped the update. Now that just happened as a matter of course from the way that I've defined my nested block. But when I switch to bulk processing, nothing happens for me automatically. So for each one of my errors, I need to log the error. But then I have to figure out how to tell the update statement, which is coming along later in a separate FORALL, not to update that particular employee ID. Now in this case, it's pretty straightforward, but it may vary a lot depending on your algorithms. What I'm going to do is go to my bulk collections, my bulk exceptions, error index. Go to that location in my array and delete that employee ID. You can't update that employee if the employee ID is gone. Great. So there's no way that the update will happen for this insert. So I finish all my inserts, then I do my updates. Now I've got a problem. My employee IDs array might have gaps in it. It might even be empty if every single insert failed. So I can't go from 1 to the count. So I'm going to switch to indices of, add save exceptions, trap any errors, and log those errors. So that's a very quick look because I have run out of time as to the conversion process. And it will give you an idea of what you need to do, but it's just the starting point. This is a very complex piece of functionality that you have to go after and apply very carefully. So to sum up, FORALL is far and away the most important performance tuning feature in PL SQL. It's going to always be the fastest way to execute repeated SQL operations that you can't execute natively in SQL. And if you can do an insert select, that's going to be faster than FORALL and BULK COLLECT, but actually not by that much. And the main thing you want to look for is that classic anti-pattern, the loops that contain non-query DML. But when you implement this feature, you've got to do it very carefully. You're going to trade off significant increases in complexity of code for that dramatically faster execution. So number 1, don't do it if you don't need to do it. If you've got a cursor for loop with no DML, leave it in place. If you've got the DML in place, analyze your code. Make sure that you understand all the aspects of how it works today, and make sure that you understand how to mimic that behavior in your bulk processing approach. And then you'll end up with a program that is significantly faster. You may consume a bunch more PGA memory, so watch out for that and use that limit clause. But it will also be more complex code to maintain, so make sure you document it clearly and write it in a way that keeps your code well organized and easy to read. And I'll just make that point, my one final point with code, by going down to the bottom of this script again. Notice that what I did was use nested subprograms to hide all the details. So these are procedures inside the other procedures that hide that logic and let me write code that is extremely readable and it's very small, concise, executable section. All right, well, I'm very sorry that I went over time there by a few minutes, but I'm certainly still ready to answer questions. So let's see what you got for me. Let's see. We had a question here. Is the last presentation on the function result cache available somewhere? And yes, you can go online to ODTUG.com. You can also go to my blog. Let's go back to that home page. Sorry, the front page. You can visit my blog, and that has a post that has all my different webinar presentations and all the links to the recordings. In addition, before I forget, let's go out to the internet. Let's go to the PL SQL Learning Library. So oracle.com/OLL takes us to the Oracle Learning Library. Do a search on PLSQL. Go to the PL SQL Learning Library. And then you can also find links to all the presentations here. And if you click on Demo Zip, you can download all the scripts that I've been showing you, and you can run these scripts yourself. So that's how you get a hold of all of my code. Back to questions. So years ago, you attended one of my presentations in Minneapolis, and I made the statement that anytime you're grabbing 25 records or more, you should use bulk collect. I would say that 25 records, I don't remember saying that, but sure, why not? It's not a bad point at which you want to convert to bulk collect. But I would say that in general, you're probably looking at more like hundreds or thousands of rows before you really ever notice the difference in performance. And again, if you're just fetching 25 records and not executing DML on them, you're almost certainly not going to need to change them. Okay, can I show an example where you do a bulk collect and then once in the for loop update the collection, then use the collection when inserting or updating a table with FORALL? I'm not sure I can even parse that question, so I'm going to move on and maybe I'll come back to it. Do we have a limit option only with fetch statement? Any reason for the same? Yes, so the question is, do we just have a limit clause for a fetch engine? And the answer is yes. So let's go back to bulk limit. So I open my cursor and I fetch bulk collect into with a limit. And I guess what this person is asking, why can't you just put a limit clause on my select bulk collect? Why can't I just say select bulk collect into from employees limit? Well, prior to 12.1, you really couldn't. You just define your data set and you populate your collection with it. Actually, with 12c, there is something of that available now, and that is the fetch first. So let's see if I can find it. So in 12.1, you can add to your select bulk collect that I want to fetch the first n number of rows only, and it will restrict how much you're fetching. But in general, if you need to do multiple rounds of fetching and limit the numbers of rows you're retrieving at a time, use an explicit cursor and a limit clause. Going through my questions here. When bulk fetching from a cursor into a collection of records and bulk fetch has a limit clause instead of exceptions, wow, these are some long, complex questions. So one part of this question is, where should we put commit statements so results of successful inserts and updates get committed when I'm working with a limit? So let's go back to my bulk collect, in which I've got my two different phases, insert and update. And as you can see, I'm doing a batch at a time. So for n number of rows for the first 100, I do it, then I do the next. Now, what you might want to do is think about putting a commit after each one of these. So for each batch of data that you've retrieved, I'm going to make the changes, inserts, updates, and commit. So that's certainly a logical place to put a commit. The question really becomes how you're defining your transaction. Do you need to go through all of these changes before you can make a commit? But certainly you wouldn't want to commit here. You're unlikely to want to commit here separately from here, because what if something goes wrong here? Then you've got a partial insert without the updates. How can I get a record and samples? Okay, so you know how to download the code now. That's good. If multiple scripts are running at the same time with FORALL, even if they're using the limit clause, could PGA be affected? So if multiple scripts are running at the same time, what that means, since PL SQL is not a multi-threaded language, that means you have multiple sessions running the same script at the same time. The PGA will be affected for each one of those, but I think the thing you're going to want to look at more than anything else are whether or not you're going to be walking over each other in terms of the rows you're modifying, either getting into deadlocks or having to go through extensive waits. So you generally want to avoid having multiple scripts running at the same time, modifying the same rows in high performance. Lots and lots of questions. Excellent. What if you want multiple selects into your collection? So when you run your select statement, every bulk collect into is for a single select statement. But that select statement could be a join across 25 different tables. If you have multiple select statements, you have to populate different collections separately. Is FORALL able to cope with invisible columns on a row type record? You know, invisible columns are something that are relatively new in Oracle. I think they were introduced in 11 and enhanced in 12. There are some nuances in terms of working with row type records. Honestly, I don't have much experience with them. But as far as I know, bulk collect will be just fine with that. You may not be able to see all those invisible columns when you do your bulk collect, but bulk collect will not fail because you have invisible columns. Can bulk collect be used with growing data like transactions for a user within a month? Sorry, don't know what that means. Should I put commit in my exception handlers? In general, I'd say no. But it all depends on what you need to do. So I think the question here might be, if I'm logging an error, should I do a commit afterwards to make sure that that error is saved? Now, you do want to make sure that your error information is saved, but you don't want to put a commit here. You want to put the commit inside your log error procedure and make that log error procedure an autonomous transaction. And I think I might have, let's see, I don't know if I have an example of the logger program at the top of this script. No, but maybe this one. So here's my log error program. I can make it a pragma autonomous transaction. And then when I commit, if I was doing an insert, this single row insert would be committed, but the outer transaction would not be affected. So if you want to commit just those logged errors, use an autonomous transaction pragma in your log program. How can we handle rollback with save points? I think that what you might be asking about there is, what if my insert worked and my update failed and I wanted to do a rollback to the start here? So I have a save point and I do a log error and then roll back to my save point. So the answer, given that it's 11:10 and this is a non-trivial question, is you can definitely engineer the same kind of behavior using bulk processing. But you'll need to think through, again, what happens now, not just how do we communicate from my insert to my update. And the way I did that here was to delete from my employees array. But I'm going to have to go figure out a way to when the error occurs for each one of the failures of the insert, I need to go back and change the update, the inserted row, essentially do a delete from my audit table for those rows. So that's essentially what would have to happen. You have to add a delete process here, in which you're able to identify the correct row in your audit table, the insert table, and then remove it. So you can definitely do it. Again, not trivial, and it's something you want to think through extremely carefully. And I believe that handles all the questions I've got. So thank you for all of those great questions. I hope you enjoyed my presentation. Do visit my blog and check out my Twitter handle, SFonPLSQL, and download that demo zip script so that you can play around with all this code yourself. Thanks very much for joining me. Happy PL SQL coding, and hopefully I'll be talking to you next month. Take care, everybody.